All right, today we are going to be multiplying and dividing rational expressions. So first we have some steps here that can be handy. I'll kind of point those out as we go through this first problem. So the first thing we want to do is factor both the numerator and denominators if we can. So on this first problem here, I notice, oh, this is a difference of squares, this kind of thing, right? If you have two perfect squares being subtracted, you can factor it like so. Let's see. What's being squared here? Well, that would be x. And then what's being squared here? Well, that would be 2. So I'll have x minus 2 times x plus 2. And then I'll just rewrite everything else here. I have 8x here, 2x on top here, and then x plus 2. All right. Now we identify any excluded values. So again, those are values that would cause any denominators to become 0. So looking at this first fraction, well, if x were 0 itself, 8 times 0 would be 0, right? So that is an excluded value. X cannot equal 0. The other excluded value comes from this fraction here. What plus 2 would be 0? Well, that would be negative 2. So those are excluded values. Now what we do is cancel or cross-cancel. And what that means is we can basically consider this, even though it's not written like a single fraction, we can consider it a single fraction. And you could cancel out this with that. Okay? Because eventually they're going to go together anyway, and one would be on top of the other. And if you recall, just with some numbers here, if you have, like 5 over 5, those cancel out. They cancel out to 1, right? Now, you don't usually have to write that 1 because if you have 1 multiplied by other stuff, you don't have to write down the 1. So that's what's happening here. That remaining 1, it will be multiplied by the other stuff. We don't have to write it down. We also have these x's that we can cross-cancel, all right? And so let's go ahead and rewrite this. Notice I put that 2 in the front. Generally, you want to keep numbers in front of parentheses. And then we have this 8 in the denominator. Now, there's one other thing we could do here. We could have done this earlier, but I wanted to sort of break it down here in steps. If you had the fraction 2 over 8, just by itself, what would that reduce to? Well, that'd be 1 over 4, right? 2 can go into 2 once, 2 can go into 8 4 times. So one way to show that, and we could have done this up here too, but let me do it like this. You could do this, right? It's like you're just reducing, you're dividing each of those by 2. And then you need to rewrite it, of course. And, this is a 1 here. It's multiplied by other stuff, so you don't need to write it. And you can actually drop the parentheses because that's the only factor up top. If you left them in, it wouldn't be the end of the world, but you really don't need them. All right, that's as much as we can do with that problem. And then you do want to state those excluded values along with your answer. Boom. Okay, there we go. All right, let's do number 2 here. So on this one, it's a little bit more complicated, it looks like. It's just a little bit more factoring we have to do. So yeah, step 1, factor everything, okay? Numerators and denominators. We can't do anything with that first numerator. I'm just going to copy it down here. The denominator here, that's a trinomial. So we need to find two numbers that multiply to negative 8, add to negative 2. Well, that would be negative 4 and positive 2. So we would end up with that. This is also a trinomial. Two numbers that multiply to 10, add to negative 3. Well, the only two numbers, so we got 1 and 10 and 5 and 2 are possibilities. Well, 5 and 2, they subtract to 3, right? And if we made the 5 negative, that would, negative 5 plus 2 would be negative 3, right? Okay, and then two numbers that multiply to 6, add to 5, that would be 3 and 2. Okay, now we identify excluded values before we cancel anything. So x cannot equal positive 4, right? Because 4 minus 4 would be 0. Anything that would create a denominator to be 0 is an excluded value. Negative 2 would be another one. -3 would be another one. And then this would also be -2. You don't need to write it down twice. All right, now step 3, cancel or cross cancel where possible. So I notice these x plus 2's cancel out. And that might be it. Yeah, it looks like it. So now I just put everything else together. So it'll just look like this: 3x squared times x minus 5 over x minus 4 times x plus 2 times x plus 3. All right? Now, it depends on, what we would need to do with this next. If this were like in an equation or something, you might have to distribute and multiply everything out. We're not going to worry about that here. You can leave everything factored. That's fine. So we're just going to leave it like that. And then you could sort of transfer your excluded values down here. Once you get the hang of this, you might be like, you know what, I'm just going to write my excluded values kind of near the bottom, just so you don't have to rewrite it. All right, so there we go. There's the answer to number 2. Let's take a look at the second part of number 2. So again, we want to factor like crazy here. So this x squared minus 8x, not a trinomial. I suppose you could think of it as a trinomial with a 0, but how I like to think of these is I notice, there's an x common to both of these. So you want to take out what is common to both. There's no number common to both, right, other than 1, and that doesn't help. So x times x would be x squared. X times -8 would be the -8x. So that's the numerator factored there. The denominator here, this is a trinomial. 2 numbers that multiply to 15 add to 8. Well, that would be 3 and 5, both positive. All right, we got that fraction factored. Next fraction over here, 7x plus 35. Again, not a trinomial, but I notice, 7 goes into 7, 7 goes into 35, so we can take that out. 7 times x would be 7x, 7 times 5 would be 35. And then this is not factorable. It's already, there's nothing we can do with that. So there we go. Now we want to identify those excluded values. I might do that thing I mentioned earlier. I might just write my excluded values down here so I don't have to rewrite it. So x cannot equal -3, -5, or -8, right? All the opposites of those, whatever would make them 0. All right, now we cancel or cross-cancel. I notice the x plus 5's can cancel. Now, it's really tempting to want to cancel out x plus 8 with x minus 8, but they are two different things. You cannot cancel those. Also, some things that you can't cancel, you can't cancel an x with like this x. This x is involved in addition. That does not work. Okay, that would be like saying, just really quick here off to the side, if we had 5 over 5 plus 7, well, that comes out to 5/12, right? Well, imagine if we said, we can cancel out these 5's, and then, of course, you would be left with a 1 up top. Well, that's not correct, okay? No. So that's why you cannot cancel if something is involved in addition, okay? Now, if it were multiplication, and I could go through and show that with numbers too, but I don't want to take the time to do that. You can try that yourself. It would work out. Okay, so yeah, you cannot cancel this x with this x, all right? So what we're left with is, I'm going to put that 7 out front. So 7 in front of the x, and then you have the x minus 8 in the numerator. And then we have x plus 3, and then since this is getting multiplied by something now, we do have to put it in parentheses. Okay, so that's our result. Oh, and look at that. I got my excluded values right to the side here, and so I'll just circle that all together as my answer. All right, you guys go ahead and do number 3 and 4 for practice. All right, so here's what I got on number 3. Don't forget to reduce if you just have numbers again involved in multiplication only. We don't have any plus between the 8 and the p, right? So you can reduce that just like you would a regular numerical fraction. So you get 1 over 2p, excluded values there. And then on this one, a lot of factoring. We had a difference of squares here. This one, for some reason, didn't pop out right away at me. You might have seen me grab the calculator to think about that one. But yeah, it's just 10 and negative 9. Add those up, you get 1, right? And then 10 times negative 9 is negative 90. And then, yeah, difference of squares, another trinomial. This doesn't factor. Look at everything that cancels out. Doesn't that feel nice when you get to cancel out that much? And so you're just left with x plus 10. I identified these excluded values before I canceled. One common error on these, you guys, is people sometimes on this kind of problem might write x cannot equal negative 10 because they see this. It's okay for a numerator to be 0. You can take 0, you can have 0 on top of a fraction. That's okay. You can have 0 divided by something. If you have nothing and you divide it by anything, you still have nothing. The thing that doesn't make sense is when you divide by nothing, okay, when you divide by 0. That doesn't quite make sense. So it's only if the denominator becomes 0 that we think about those excluded values.